We go back to the top. You've probably seen this problem before where if somebody says they'll give you a penny on the first day, so February 1st, I'll give you a penny, and then I'm gonna double your payment until the 28th, right? How much money will you have at the end of the month? Anybody done that problem before?
28 cents.
What's that?
28 cents.
Oh my god.
What?
Basic.
Did you hear
You
what
get
he
a
said?
penny on the first day. And on the second day, you get 2 pennies, and you get 4 cents, and then you get 8 cents, and then you get, got it now?
Yeah,
Okay,
that was,
so, alright, so here are some generic examples. We'll go back to that particular problem and I'll show you a way that you can solve it, but if step 1 has an 8, step 2 has a 2, step 3 has a -4, step 4 has a -10, right? So what they're doing is they're telling you, okay, you should know the pattern by now, so we're gonna skip a bunch of writing down a bunch of steps, and we're gonna get out to number 10, what is it? So what's the recursive rule to produce the numbers in this chart? So as you look at this, you can tell what's happening, right? They're probably simple enough numbers that you can see it, but if not, subtracting 6 does work. So to write a recursive rule, we need a starting value. They start us with what term?
1.
1. So you're gonna write down u sub 1 is equal to what? 8. The rule then, u sub n, you're telling somebody if you wanna find any term in the sequence, do this. Okay, so take your last number, the last number that you know, un minus 1, and do what? So take your most recent answer, tell them to subtract 6, and it should generate this rule. Probably the easiest way for you guys to do a problem like this, if you have your calculator, with recursive, is to type in 8 and hit enter. What that does is that throws it into the calculator, and then you can say, either hit second negative or just hit the minus button, and it will say take your last answer and subtract 6. So your calculator kind of looks like a recursive rule right there. So that's step 1. There's step 2, 3, 4, 5, 6, 7, 8, 9, 10. You didn't really have to do anything, let the calculator do the work. We got -46. Can somebody explain what was happening in the red numbers?
Like, it's not an arithmetic problem, it's a geometric problem.
Do you know what's happening in the red numbers though?
Well, like,
What I was doing?
you were subtracting 160 and 400, gain the 240 number, then you were subtracting 160 and 64, you got 96.
So I was saying we took the next number, the 160, and subtracted the 400, and I got 240. So it's possible this is arithmetic with a common difference of 240. But when I take the next set of numbers, the 64 minus the 160, I got 96. So it can't be arithmetic because they have to have the same common difference throughout the pattern. So now we're gonna go over and check for geometric. So you can take 160 and divide by 400. What do we get? 1/4? 0.4, thank you. And what's 64 divided by 160?
0.4.
0.4, right?
Yeah, that's one.
And then if I take my 25.6 and divide by 64, I should also get my 0.4. So if you take, when you go to check for geometric, if you take that next number and divide by the one right in front of it, and you keep getting the same number, then you know it's geometric. So remember, recursive rule, where did they start us this time?
0.
What they call a zero term. So you write u sub 0 So that's the starting value that you give the person. And then the rule, UN is your last number, and what do we multiply by? Times 0.4. Gonna clear that. We started at 400. I hit enter, and we're multiplying by 0.4. So that's, you gotta remember now you're counting starting with the zero term. 400 is a zero term. So that's 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's call it 0.0419. The week of February 14th, the owner of Nichols Appliances stocks hundreds of red heart-shaped vacuum cleaners. The next week, he still has hundreds of vacuums. He tells the manager, discount the price 25% each week until they are gone. On Valentine's Day, each vacuum was $80. What is the price next week? So, they are priced at $80. Then they start the discount. Correct? So, on Valentine's Day, each vacuum is $80. What is the price next week?
$60.
Well, if the discount is 25%, right? Some of you will do what is 25% and then subtract that from the price, right? If it's a 25% discount, that's what some of you will do. I would ask you in this question, if they're discounting the price 25%, how much do you still, what percentage are you still paying? You're still paying 75%, right? So I might do 1 minus 0.25 in my head to get this 0.75 number. This is what you're still going to pay, right? Now, first of all, one of the things that I skipped over is when you're dealing with the percent, switch to the decimal right away, correct? Always divide by 100. So 25 divided by 100 is 0.25. So when I walk into a store and they're running a sale, I don't calculate the discount and then subtract it from the price. I calculate what I still have to pay. So on Valentine's Day, each vacuum was $80. Next week, I take my 80 times 0.75. What do we get?
60.
So in that first week of discount, so the vacuums were there on Valentine's Day. Now the next week, they start discounting the price. So the first week of discount, they're down to $60. What is the price during the fourth week? So 80 times 0.75. Week 1, week 2, week 3, week 4. So they're all the way down to 25.31. So in the fourth week. So this brings up that point of paying attention to, is it a use of zero term they're giving you or a use of 1? Finally, when will the vacuum sell for less than $10? Well, if that's week 4, week 5, no. Week 6, no. Week 7, no, it's not under.
It's week 8.
Week 8. So it took 8 weeks, and we'll just write it in there, $8.01 if you round it properly. week 8. So let's go back to this problem. One of the things, and I'll teach you a method to do this a little more accurately on your calculator, but we're gonna just do it this way. It's pretty cumbersome to count out 28 times, but that's day 1, and now we multiply by 2, right? Because we're doubling it. So that's day 2, 3, 4, 5, 6, 7. So at the end of the first week, you're getting paid 64 cents at the end.
But isn't it asking for the equivalent? Like the sum of it all? That's what it's
Yeah, we're not gonna actually add these up.
saying. Okay, we're just finding what
Yep.
you're paid for.
Yeah.
Okay.
I'll show, we'll look at it way, but that's week 7. I mean, you could write them down and add them up too. 8, 9, 10, 11, 12, 13, 14. So we're halfway through the month and one payment is $80.92. 15, 16, 17, 18, 19, 20, 21. So by the end of the third week, we're getting paid $10,000 on that day. 22, 23, 24, 25, 26, 27, 28. That's $1.3 million. 670,000, 335,000. So already, right on the screen, the last 3 days, you're getting over $2 million. Doesn't take long when you start doubling that exponential growth. So we'll show a way that'll be a little more accurate, a little bit easier. You guys don't have to sit there and count, and you get to use your calculator, so that'll be good.